Hello students. So in the previous class we had discussed about one or two graphs and how we can plot a graph using that table, using the table that is given for velocity. Like if they have given velocity and time table for different values, so we can plot a graph using velocity and time values. So let's derive an equation using those two things, that is velocity and time. So in today's class we will see two basic equations. So in the next class we will see one more equation and solve some of the problems related to that. So first, when we take graph, this is time and this is velocity. Suppose say that an object is traveling with some initial velocity and its velocity keeps on increasing for every interval of time. So an object is starting with some initial velocity, so this velocity, and the velocity keeps on increasing. So this is a straight line. Here, if we have to find the acceleration, so using this graph or using this value, if we have to find the acceleration between or for any particular period of time, so what we need to do? So we know that acceleration A, that is change of velocity divided by time, or we can define acceleration as rate of change of velocity. So acceleration is change of velocity divided by time. So here we are saying change of velocity. When we look at this graph, so this part is initial velocity because it's starting with some values. This, the entire part is final velocity, that is v. So it has attained some velocity. So here, so it is starting from the, so this is initial velocity. This entire thing is final velocity. So when I say change of velocity, that is difference between the final velocity and the initial velocity will give us the change of velocity. So what is this change of velocity? So if we have to, so just understand the concepts. So if you understand the concepts, so you can easily solve any of the problems. So if you go with the textbook, so they are given, okay, this is O, A, B, C, D, so on. So I am trying to explain you in easier way. So change of velocity. So change of velocity andre ಏನು? ಇದು ಈ ಕಂಪ್ಲೀಟ್ ಈ ಹೈಟ್ ಅಂದ್ರೆ ನಮಗೆ ಒಂದು ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಬೇಕು. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಇಲ್ಲಿಂದ ನಾವು ಹಿಂಗೆ ತಗೊಂತೀವಿ. ಸೊ ನಮಗೆ ಇಲ್ಲೇನೋ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಸೊ ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ? ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಆಗಿರುತ್ತೆ. ಸೊ ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ? ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ. ಸೊ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿಗೂ ಫೈನಲ್ ವೆಲಾಸಿಟಿಗೂ ಡಿಫರೆನ್ಸ್ ಏನಿದೆ? ಅದೇ ಚೇಂಜ್ ಆಫ್ ವೆಲಾಸಿಟಿ. ಸೊ ಚೇಂಜ್ ಆಫ್ ವೆಲಾಸಿಟಿ, ದಟ್ ಇಸ್ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಮೈನಸ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ. ಸೊ ಫೈನಲ್ velocity minus initial velocity divided by time. So ಇಲ್ಲಿ final velocity, it is represented by v, initial velocity u, so minus it, so minus the final velocity is initial velocity divided by time t. So this is equal to acceleration. So ನಾನು t ನ LHS one thing. So LHS ಕಡೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ T A ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ. So A into T, that is AT. So is equal to B minus U. So T LHS ಬರುತ್ತೆ. So LHS ಬಂದಾಗ ಏನಾಗುತ್ತೆ ಇದರ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ. So A into T. So minus B minus U. Minus U ನೋಡೋಣ LHS ತಗೊಂತೀವಿ. If minus U comes to LHS, it becomes plus U. So minus U LHS ಮಾಡಿದ್ರೆ AT plus U is equal to B. So I'll just rearrange. So V is equal to U plus AT. So this is one important equation. That is V is equal to U plus AT. Initial velocity is equal to final velocity V. Final velocity is equal to initial velocity plus acceleration into time. So A is acceleration, T is time. So this is one important equation. So this is one. Next, using the same graph, if we have to find the displacement. So displacement, the formula displacement is equal to velocity into time. So displacement is velocity into time. So velocity y axis alide, time x axis alide. So ಇದು x axis, this is y axis. So ಇದೆರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ನಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಸಿಗುತ್ತೆ. So this is nothing but the area under this graph. So a complete area, ಇದು ಒಂದು graph. So let's draw. ಇದು ಗ್ರಾಫ್. ಸೊ ಈ ಗ್ರಾಫ್ ಕೆಳಗೆ ಏನು ಏರಿಯಾ ಇದು, that is nothing but displacement. So I need to find this entire area. So this entire area gives me displacement. So displacement is velocity into time. So how do I find this area? So if you observe this is like a trapezium. So trapezium andre it has two parallel sides. So trapezium alli properties nodidre it has two parallel sides. So this and this are parallel. So they are parallel, and so it can have any particular thing. So but it is having some height. So if I take this length to be A, this to be B, or if it is getting confused with acceleration, so let me take this to be x and this to be y. So the height of trapezium is h. So if I want to find the area of trapezium is half into height into sum of half into height into sum of parallel sides. Half into height into sum of parallel sides. So half height ಏನಿದೆ h into sum of parallel sides. Parallel sides x and y. So sum of parallel sides andre x plus y. So this gives me the area of trapezium. So if I apply the same formula here, so ಇಲ್ಲಿ parallel sides idu u, this complete is v. So idu parallel sides. Height idu height agade because entire time x axis y axis perpendicular irutte. So we can consider this length as height because these are perpendicular irutte. So this can be taken as height. This is t. So for a particular time period. So there t agutte one parallel side distance u, another parallel side distance v ಅಥವಾ length v. So ಈ area of trapezium ಹಾಕಿದಾಗ, so area of trapezium ನಮಗೆ ಇಲ್ಲಿ ಏನು ಕೊಡ್ತದೆ ಈ particular situation ಅಲ್ಲಿ displacement. So I represent displacement as S, capital S, is equal to area of trapezium half into sum of parallel sides, half into height ಇಲ್ಲಿ t. So now trapezium ಹೆಂಗಿದೆ ಅಂದ್ರೆ ಈ ತರ ಇದೆ. So ಇದು time u, initial velocity, this is final velocity. So trapezium ಹೆಂಗಿದೆ, so ಇದು height, initial velocity, final velocity, sum of parallel sides. So height is t, sum of parallel sides u plus v, u plus v. So ನಾನು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ, 2 ಮೇಲೆ ಹೋಗುತ್ತೆ, 2s is equal to t into u plus v. So ಇಲ್ಲಿ s 2s is equal to t into u plus v. So this is one equation. So ಇಲ್ಲಿ ನಮಗೆ ಟೈಮ್ ಇದೆ. Now before ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಇನ್ನೊಂದು ಈಕ್ವೇಷನ್ ಬರೆದಿದೆ. ಸೊ ಆ ಈಕ್ವೇಷನ್ ಏನು, v is equal to u plus a t. ಸೊ ನಾನು ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, v is equal to u plus a t ಇದೆ. ನಾ ಈ ಟೈಮ್ ಜಾಗದಲ್ಲಿ ನಾನು ಬೇರೆ ಏನಾದರೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಸೊ ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಸೊ ಟೈಮ್ ಇದೆ, ಸೊ ಈಕ್ವೇಷನ್ ತಗೊಳ್ಬೇಕು. ಸೊ u ಈ ಕಡೆ ಕಳಿಸಿ. ಸೊ v minus u is equal to at. ಸೊ ಏನು ಕೆಳಗೆ ಕಳಿಸಿ, v minus u divided by a is equal to t. So let me take this as equation 1. So equation 1, v minus u by a, this is equal to time. So ಈ equation ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. In place of t, I am substituting t ಜಾಗದಲ್ಲಿ v minus u by a. So ಏನಾಗುತ್ತೆ, 2s is equal to time ಇದೆ. So time ಜಾಗದಲ್ಲಿ ಏನಾಗುತ್ತೆ, v minus u by a. v minus u divided by a. So this into u plus v na v plus u ಅಂತ ಬರೀತೀವಿ. So u plus v ಇದೆ, v plus u ಅಂತ ಬರೀತೀವಿ. So just change ಮಾಡ್ತೀನಿ. So if you remember this is an identity, that is x plus y into x minus y. Identity, you must know this identity, x plus y into x minus y, that is x square minus y square. So this is an identity. So similarly here in barutte v minus u into v plus u, v square minus u square. So a ಕೆಳಗಿದೆ, ಏನಾಗುತ್ತೆ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ 2as. So this is also one more important equation, that is I'll write it here. 2as is equal to v square minus u square. So this is one more important equation. So this is one equation. So this is one more important equation. So this two are, this is one equation and this is another equation which is derived from the same graph. So the next class, let's see how we can use the same graph and same area in a different way to get one more equation. Next class ನಾವೇನು ಮಾಡೋಣ, ಇದೇ ಗ್ರಾಫ್ ನಾವು ಏರಿಯಾನೇ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಬಟ್ ಏರಿಯಾ ಹೆಂಗೆ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ, ಏರಿಯಾ ಆಫ್ ಟ್ರೆಪೆಜಿಯಂ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಲ್ಲ, ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಇಸ್ ಒನ್ ಟ್ರಯಾಂಗಲ್, ಇದೊಂದು ರೆಕ್ಟಾಂಗಲ್. ಸೊ ರೆಕ್ಟಾಂಗಲ್ ಏರಿಯಾ ಆಫ್ ರೆಕ್ಟಾಂಗಲ್ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ, ನೆಕ್ಸ್ಟ್ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇದೆರಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಏರಿಯಾ ಆಫ್ ಟ್ರೆಪೆಜಿಯಂ ಅದು. ಸೊ ವಿಲ್ ಸಿ ಹೌ we can use the area of triangle plus area of rectangle to get one more equation, that is s is equal to ut plus half at square. So that is one more equation. So today we saw v is equal to u plus at, 2as is equal to v square minus u square. So these two are very important equation. One more equation is s is equal to ut plus half at square. So these three equations which you will be studying now will be useful not just in your 9th standard but even when you go to 11th, that is first PU. You get the same equation, so same set of problems. So problems are change agala, equation change agala, equation same irutte, method same ide. So ನಿಮ್ಮ ಮನೇಲಿ ಯಾರಾದರೂ ಫಸ್ಟ್ PUC ಇದ್ರೆ ಅಥವಾ when if you search online you will get first PUC textbook. So first PUC textbook open ಮಾಡಿ ನೀವು ಸೇಮ್ ಈಕ್ವೇಷನ್ ನೋಡ್ತೀರಾ, ಸೇಮ್ ಡಿರೈವೇಷನ್ ನೋಡ್ತೀರಾ, ಅಲ್ಲಿ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ, ಪ್ರಾಬ್ಲಮ್ಸು ಆಲ್ಮೋಸ್ಟ್ ಸಿಮಿಲರ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಹೋದ್ರಿ ಫಸ್ಟ್ PUC ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಇಟ್ಸ್ ನಾಟ್ ಜಸ್ಟ್ ಫಾರ್ ಫಸ್ಟ್ PUC, ಇವನ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಸಮ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸಸ್. ಸೊ ನೀವು ಹೋಗಬೇಕಾದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದರೆ ಅಥವಾ ಏನೋ ಪ್ರಾಕ್ಟಿಕಲ್ ಸಿಚುವೇಶನ್ಸ್ ಬರುತ್ತೆ, ಸೊ ಅವಾಗೆಲ್ಲ ಈ ಈಕ್ವೇಷನ್ಸೇ ಯೂಸ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ ಬಿ ಪರ್ಫೆಕ್ಟ್ ವಿತ್ ದಿಸ್. ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ I'll solve some more problems and we'll derive an equation. So that's all for today. Thank you. Have a great day.